Hello everyone, welcome to my video. In this video, let's look at general plane motion for rigid bodies. Once again, I would like to emphasize the two basic governing equations here on the left. When solving general plane motion problems, there is a general procedure that I recommend you to take, especially as a beginner. Step 1, you should choose or set up the proper coordinate system. As I mentioned in the last video, x, y, and nt systems are the two most common ones that we'll be using. Choose proper points to establish moment equation. Step 2, you want to either choose point O, which representing the mass center, or P versus Q. Q is the center of percussion, and P, it can be any point, but usually we pick that convenient point, can reduce our calculation, such as that point has so many forces going through, so you only end up with a few forces only, or even one force or no force, making moment with respect to that particular point P. Step 3, identify constrained motion. Use relative motion analysis techniques as needed. That was from chapter 5. Sometimes you can use absolute motion analysis, that's fine. Sometimes, especially for constrained motion, you want to consider use the relative motion analysis techniques you learned. And step 4, know how to calculate I naught, which is the mass moment of inertia of the body. Know how to read the table in your textbook. Since there are not really much new concept here in this section, the governing equation is the same. So let's look at one example to see how these equations can be used. Please take a moment to read the question first. First thing first, we will get our free body diagram. There are gravity, normal force, and friction. Then setting up coordinates. This is a translation motion, so XY system makes the most sense. As for many hill or ramp related questions you have encountered, the XY system can be set to be tilted at an angle the same as the ramp, which will help us simplify our calculation, especially when we're splitting the forces onto x and y directions. With that, we can get the sum of fx and sum of fy, as well as the sum of moment of the mass center g. Here I would like to point out, for a tire like this, which can be treated as a thin ring, then I can be calculated using the mr square. This is how I get fr equals to mr square alpha. Just as a reminder, this is the equation can be used for thin ring when it's rotating with respect to the rotating axis is at the center of the ring. From the sum of fx and fy, we can get the friction is 2.455 m. Now the m is mass. I'm not subbing any mass number here because I don't know the mass. So 2.455 m. M representing mass is unknown, and the normal force is 8.496 m. Then, from the sum of moment equation, we can calculate the acceleration is 2.45 meter per second squared. Seems like pretty easy and straightforward, but is that all? Well, since I'm asking you like this, of course not. When it involves friction, we always want to double check if there is enough friction force to prevent from slipping, or if there is any slipping happening. The static friction coefficient is 0.16, can give us the maximum 1.359 m static frictional force. But from the calculation, we need 2.455 m, which is more than a static friction. Therefore, the tire is slipping while rolling down the ramp. It's not no slip. If there's no slipping, then you can safely use a static friction. But there's slipping, so you have to use the kinetic friction coefficient. Therefore, we will have to use the kinetic friction coefficient in our calculations to get F equals to 0.8496 m. And then sub this friction into the fx equation to get the correct acceleration. A is 4.06 meter per second squared. And then finally, we can use the moment equation to calculate the correct angular acceleration alpha, 2.43 radians per second, using the mr square alpha, which we obtained at the beginning. Now, we have the final correct answers. So again, just to quickly recap about this question, especially when friction is involved, and in the question you were given both mu s and mu k static and kinetic friction coefficient, be careful to choose which one you need to use. Sometimes you need to make a judgment, sometimes you need to calculate first and then compare whether the static friction is enough to support the motion without slipping. This is a list of recommended readings. For sample problem 6/7, although you may find it is very geometry intensive, it is required. You need to know how it works. Sample problem 6/8 is not required, but good to know. Thanks for watching. I'll see you next time.